And before we start, I want to say a few words about myself. So originally, I'm a mathematician, but even in my earlier life in academia, I have already juggled with big data, because I was doing computational group theory, working for a computer algebra system, and so therefore I was enumerating orbits and doing lots of interesting stuff with big data. So now I'm working in database development. In more detail, I work for a company called ArangoDB, and we develop a product called ArangoDB, and this will feature a little bit in my talk, because it is one of these multimodal things. Right. So if you don't know what NoSQL is, don't worry. You don't have to, and in a sense, I don't know it myself, because it's not so well defined. But what is well defined is different data models. So let's look at a few. The first data model I want to introduce you to is a document store. And when I say document, I mean JSON document. So a document store stores JSON data without a schema, and it collects these things in something like collections. So I see you taking images. Go ahead, no problem, but I will post the slides on SlideShare tomorrow, and will post the link to the thing on the meetup page, so you will have access to these slides. In a document store, each document of a collection has a unique key, and you can have secondary indexes, because the database knows it's JSON, so it can inspect the things, but it doesn't enforce a schema. The different documents in the same collection can vary its structure. They can be whatever you want to throw. So you don't need a schema, but obviously in most applications you will have a schema in your mind at least. In a document store, you can relax data normalization. In fact, in many document stores you have to, because you can embed sub-objects in these JSON data, as we have, for example, seen in the meetup page. Something like the venue was an embedded JSON document, which was just assigned to an attribute in the enclosed JSON. So because every document has a unique key, it is a key value store, but in a normal key value store, and that's the second data model I want to talk about, you usually have just the mapping from key to value, and the value is some kind of opaque data, any binary blob or whatever. So the key value store in particular can usually not inspect the values, can therefore not have secondary indexes, and the only lookup you can essentially do is by key. But what you get in comparison to other data models is a very, very high performance. It's essentially a hash table just on disk. And you get perfect scalability. You can scale out as you wish, because the query operations are relatively simple. So here you go. Document stores and key value stores are related, but not quite the same. Something seemingly completely different is a graph database. So when I mean graph, then I mean the mathematical graph in the sense of vertices and links. So like, for example, the Facebook graph is a social graph, and the people on Facebook would be the vertices, and the friendship would be the links. A graph database, well, it stores graphs. Okay, but you can store graphs in any other database. The thing is that what you need for a graph database is that you can query it in a graph-like fashion. So what is interesting about graphs? For example, things like find me the shortest path from here to here, or find me all the shortest paths, or explore the neighborhood of something. That is kind of a graphy query, how I call it. And that's what a graph database is good at. So it's not so much storing graphs, it is actually asking sensible questions about graphs. Yes?
You have both vertices and edges as units. Is there something analogous to a record or are there these basically two kinds of things?
It depends how it's done. Graph databases vary very widely. For example, one way to say is every vertex is a document, JSON document, and every edge is another one, which just happens to recall where the edge comes from and where it goes to. That's one way to do it. Another way would be two tables, one for the vertices and another for each edge. Another where each row in the second table is an edge. Yes?
So just like Neo4j is leading graphic database, right?
Yes.
So
in some sense it's leading, there's others. But I think with respect to users it's probably the largest, yes. Right, so my point is that what you need for a good graph database is a good query language. So the querying is the important thing for graphs. Although this is clearly considered a NoSQL thing, scalability is a big problem. Because the moment you distribute your graph over many machines, and you have questions which need hops between edges, between long edges, then if you happen to have to hop from one machine to the other, you get communications, and therefore the performance suffers. And that's actually not a really solved problem, how to really scale a graph database. There's a lot of graph databases out there, but not much standardization.
So there's another company, it's called Objectivity.
Object data store?
Yeah, object.
Yes.
I mean,
there's other data models.
They are running on Mesos. So
yes.
Yeah.
Well, what do you think about NoSQL database like MarkLogic? Does MarkLogic run on containers?
Okay, so this is a question which is relatively unrelated to this talk.
Yeah, I'm just curious, you know.
I'm happy to answer this. It's just that we have only 30 minutes for this talk. Please ask me after the talk,
sure.
And I will happily give you an answer to this question. Right, so let me go towards the multi-model idea, but I have to push something in between. There's a very nice software architecture idea out there which is called polyglot persistence. Polyglot persistence, in my words, and originally it was coined by Martin Fowler, in slightly different words, is use the right data model for each part of the system. So if you have a complex software architecture, you should use in each part of the system the right data model. It's kind of obvious. For example, if you have to store objects, you would probably somehow store a JSON somewhere. If you have a hash table in memory, you probably need a key-value store. For relations between objects, you need a graph database. And so on and so on. I skip over the details. Obviously, if you have kind of certain types of data, you want to persist it in the right way. Notice that the traditional way to model things like this is we use a relational table-based database for everything, and you have complicated object relational mappers for that. So the idea of polyglot persistence rather is to use a persistent data model which fits to the data you originally have. And obviously, whenever you do that, you have to take scalability into account. So let me run you through an example. A typical use case is an online shop. Let's see what data we have there. We have customers, we have products, we have the shopping cart, because obviously every online shop has a shopping cart in the right upper corner usually. You have order and sales data, and you want to have a recommendation engine. Now, if you look at all these different types of data, then you see that you probably store your customers sensibly, according to this polyglot persistence idea, in a relational database. Whereas your product data, you might have very different data for each product. You probably want to store it in a document store like MongoDB. For shopping carts, that's not very important data in the sense that if it's lost, well, then somebody lost his shopping cart. It's not a big deal. But it needs to be very fast. So you need a key value store, maybe just in memory. Again, so order and sales, you probably want to store in a document store. And when it comes to recommendations, you have graphs. So here you go. There's one software product, one software application, but you need 1, 2, 3, 4 different databases. It's clear that the DevOps won't like that. So the idea of polyglot persistence, as much sense it makes from a software architecture standpoint, it has as a consequence that you have more difficulties to deploy and maintain the whole system. So you get some friction. You get synchronization problems between the different data stores. You need to convert data between them. You have increased effort for administration, deployment, DevOps. And you need to train your employees with lots of different technologies. So, summing up, polyglot persistence and knowing all these data models seems to be a nice idea from the software architecture standpoint, but it would be nice if we could reap these benefits without the disadvantages I just mentioned. Right? So, what to do? This is, and now I'm coming after 10 minutes to the actual topic of this talk. The idea I want to present to you today is the multi-model approach. So if you look the NoSQL database market, and what you see is a lot of products, 180 products to name, yeah, and so on. But mostly each of them concentrates on a very special data model. Well, not anymore, as we will see in a moment. I want to coin this term multi-model database. So a multi-model database is a document store, a graph database, and a key value store all at the same time. And coming back to your question, in this case, we would store the vertices as documents in a vertex collection and the edges as documents in an edge collection. So, but as I told you, storing graphs is easy. The crucial thing, and that actually belongs to the definition of a multi-model database, the crucial thing is that you have a single query page to be able to conveniently ask questions about all these three data models. And if possible, you want to even be able to mix in a single query the different data models. So for example, you want to get yourself, by some selection criteria, some documents. They are now the vertices in the graph. You want to run a graph traversal of a certain depth for each of these results. You get yet more results, and maybe these results you want to join to, say, yet another collection by some other criteria. And that is something really complicated which you want to express in an easy way in your query language. Now, I've chosen these three data models in my presentation, and it's chosen here in the multi-model database, because the funny thing is, a thing combining exactly these three data models is more general, but it can compete with specialized products. So there's no reason why a multi-model database, which is a document store, should be worse at being a document store than a specialized document store. Just that it has additional graph features doesn't make any problem. Likewise, this document-based approach is a good way to implement a graph database. So therefore, once you get the querying right, there's no reason why such a product should be any worse as in being a graph database than a specialized graph database. And then you have additional advantages. So in a sense, a single database suddenly allows you to do polyglot persistence, but it's only a single product. You can keep, if you want, the data in the same database. There's no conversion, no synchronization. It's, in a sense, polyglot persistence done right. Yes?
Maybe this is the answer. You didn't mention anything about having a schema.
Yes. I'm happy to talk about schema in 10 minutes' time, because then I have things. Usually, such a multi-model database is schemaless in the beginning. But in 10 minutes' time, I'll tell you something else about it. Yes?
So, looks like you are claiming with such kind of unified magical data model from a software architecture's perspective, you can solve the scalability issue, not necessarily relying on hardware architecture in terms of scalability, and also your unified data model can tackle can solve also support ACID as well as tackle the issues of CAP 0. You handle everything?
Well, no.
Are there any overhead?
First of all, I'm not saying that CAP theorem is wrong. I'm not saying I'm solving all problems out there. I'm not claiming that I do all data models. What I say is that document store, graph database, and key value store can sensibly be combined into a single product.
But there will be overhead, significant overhead.
What overhead?
If you model them, I'm not sure it's a unified or not. If you are unified, there are different overhead, memory overhead, disk space overhead, a lot of overhead.
No. These three data models fit together. It's not that we do tables as well and columnar store as well and whatever. No, it's just these three. And these three work together well such that there is a very little overhead. But again, I'm happy to discuss this later.
It's a schema-based approach or schemaless or somewhere in
It
between.
is schema-less with some caveat, which I will mention in 10 minutes time after my...
Does that support a transaction like
Yes.
this?
Well, a multi-model database you can define with transaction or without. When we come to ArangoDB, you will see that we do transactions. Right. So let me just show you two more use cases where such a multi-model thing really makes sense. And I think I'm already a little bit behind time. So let's go quickly through these. This is one of our customers who actually use ArangoDB. They do aircraft fleet management. So they have the problem that they have lots of aircraft. An aircraft has lots of little parts and greater components. And so what they, for example, need to say, if I have to exchange this type of screw, what are kind of is the smallest piece of an aircraft which I can exchange to exchange this piece? And what are the maintenance intervals and so on? Anyway, what they do is they store each part, each component, each unit and each aircraft as a document, and they do containment of parts into components as a graph. Because sometimes they need things like what parts are contained in this engine, say. Yeah? So that's a graph traversal. But at the same time, they need to ask about all the fleet across the graph structure. They need to ask, give me the things which need to be maintained in a week's time. And so that's a prime example where this multi-model approach not only helps you to store the data, but also to support all the questions you might have about the data due to this single query language. Right, so the thing here is it's needed to store the data and to answer all the questions they have about that data. And you get good efficiency for all needed queries. Another example, and I just run quickly through it, is a family tree. A family tree is obviously a graph. After all, a tree is a graph. And likewise, sometimes you have graphy questions. You have questions where you just want to find all the people, all the children and children's children and so on of one person. That's a graph query. But then you might want to have across the whole family tree all people who are called John, say. And that's suddenly orthogonal to the graph structure. And so therefore, here are some examples in more detail. But again, the data model, the data modeling is possible because it can do graphs. But if you look at the queries later, you need graph queries and you need other queries. And that's where multi-model shines. Yes?
So you said you can replace to a large extent RDBMS, right?
Yes.
Now RDBMS relational model replaced network model with normalization, join, and all those things. And that that eliminates insert, delete, update, repetitions, and all those things, which are not there in graph databases. They're kind of like a network model existing earlier. You have to update in many places, insert in many places, so you cannot really replace RDBMS.
Well, let me say it like this. If a problem is susceptible to be used to be modeled in a relational world, then it's probably better to use a relational database. Having said that, the multi-model approach, and now forget the graphs, because the graphs you don't need to emulate a relational system. If you just take for each table a collection and for each row a document, which now happens to have the same structure in the collection, then you essentially have stored the table exactly as you want. And if the query language of the multi-model approach actually allows you to do joins and everything you can do in the relational world, then yes, a multi-model, without using the graph functionality, can replace a relational database. That's not to say that if you have a pure relational database problem that you should replace it. It's just saying that the multi-model idea has a very, very large solution space, including a lot of things you would traditionally do with a relational model. And now imagine a company which does know that it needs graphs and it knows it needs documents. Then it's highly likely that they love such a product where they can additionally store tables in the form of collections. So that's what was meant by that. Okay. On the market, things are happening. Just recently, there's indications that a lot of specialized products go multimodal. Yeah? For example, Basho, who makes React, which is traditionally a key-value store, has added support for documents in the 2.0 version last year. Redis is a traditional in-memory key-value store, but they are adding more and more data types in the values, so the value is no longer opaque, and they have more complex operations. So that's somehow increasing their data model. FoundationDB is a new player, a relatively new player, which is a distributed key-value store, but which does additional layers on top to be able to be used as a SQL engine or whatever kind of data model. Yeah? And finally, there's products like OrientDB or ArangoDB, who really call themselves multi-model database. Actually, FoundationDB does this already. So, in this sense, I want to make the point that there's a lot of movement in the market which goes towards more flexibility in the NoSQL market. Another news about this, just in February, Datastax, which does the commercial version of Cassandra, has acquired Aurelius, which was creating the graph database TitanDB. And Datastax has announced that they want to have a professional product which does graphs. And at the same time, Titan is probably discontinued. And so you can see such a big player. Here are some citations from their website. Such a big player doing a big columnar store wants to support graphs as well. And finally, the recent release of MongoDB, which is a pure document store at this stage, has announced that they do pluggable storage engine. So again, they want to be able to replace the storage engine by something else, which is probably better suited for graphs. I don't know. We'll have to see what they do. For their case, it will be very interesting to see how they extend their query language, which is really close to document business, to other data models. But in any case, it's an indication that something is going on. Yes?
I missed something about the difference between key-value store and document store.
Yep.
That one is in memory.
Not necessarily, but but there are very popular key-value stores which are only in memory.
Yes.
So the difference is strange to make, because in a sense, a document store is a key-value store because it maps keys, the primary key, to documents. But it's more, because it can inspect the values.
The key value can't?
No, the document space, because it knows that the values are documents, JSON documents. So therefore it's more in a sense.
It's more.
So it has more structure, more possibilities for querying usually, but in a sense it is a key value store. And if you just talk about key value store, it's somehow something general, something which just maps key to values. Right, I've only a few minutes left, so let me tell you a few words about ArangoDB. ArangoDB is a multi-model database, exactly as explained, and it is so by design. So it was started in 2012 with this idea of multi-model in mind. It is open source using the Apache 2 license, and its API is via REST HTTP. We have a query language, AQL, ArangoDB query language, which is similar in spirit to SQL, but which is designed to mix the different data models. So you can do graphs, you can do key lookups, and you can do joins, you can do all this in a transactional way. It is memory efficient. That comes to the rescue when you want to use it instead of a relational database, because it recognizes that the documents are all the same shape. Yeah? We use JavaScript, in which we implement the higher levels of the API. The high performance part for the low level operations is done in C++, in which it is developed. And you can even use the JavaScript interpreter to extend the API with your own code. So you can adapt the database's API to your specific needs for a project, which we formalize in the Fox framework. There's a lot of drivers for many languages. There's a web front end, good documentation, and support. And obviously it's distributed. and where such as you can do automatic sharding and scale and so on. I want to emphasize two aspects of that. This answers now one of your early questions. We have configurable consistency. So you can use it as a document store by just saying, okay, I want document level operations, and it's just atomic with respect to single documents. But you can also do transactions which span multiple documents and multiple collections. So in that sense, you have the asset guarantees if you need them. For complex queries in this query language, it does snapshot semantics, and the durable storage is append only, and we store multiple revisions as needed to be able to behave in a transactional way. All this works for documents and graphs, because I told you that graphs are implemented by just having the vertices to be documents and the edges as well. In the near future, we get rid of some locking, and we will offer the same asset semantics even in the cluster, obviously in an optional way. So the consistency guarantees are configurable. And to say a few more words about this extension business and why it is sensible, and this answers yet another question of you about schemaless. The database is schemaless in the beginning, but since you can extend the API, I just define new HTTP routes by your own JavaScript code, which runs in the database server. And you have a framework for that. What you can do is you can now build API extensions which enforce the schema.
On the fly.
On the fly. You can, for all your write operations, go through your own API, and later in the project, in the beginning you want to be agile and flexible and without a schema. But once you understand your own schema, you want to extend the API with a few lines of code to make your write operations enforce the schema and enforce whatever security you need.
Yeah, still there will be a sort of performance penalty.
Obviously, but you, as the user, can now decide. And since it's run on the database server and uses the V8
looks like
engine,
there's a startup, small startup, kind of open source project. Is it like headquartered in Germany?
yes, headquartered in Germany, in Cologne, small startup,
Oh yes.
doing an open source product, selling services, that's it.
So you work with this company?
Yes, I'm employed by this company, so therefore I excuse my sales pitch.
And you are, is there any sort of branch here in Silicon Valley? No?
Not yet, but we are working on this very hard.
I see.
Right. So in the abstract, and I know I've only 2 minutes left. In the abstract, I promised some kind of predictions for the database market.
Yeah, good.
So apart from ArangoDB, let's go to this part now.
All right.
First of all, this is just 2 more slides. First of all, let me, on the first slide, just sum up a few observations about this market, which I make today, and of course all this is my personal opinion, and which I have already mentioned to some extent. So if you look 2 decades ago, there was a very, very rich market of relational databases. And what happened is a consolidation in which, from my observations, the most versatile solutions won. Oracle, MySQL, PostgreSQL. There was some standardization, yes, but also those which were the most flexible and versatile actually made the race. The other thing I observe is that more people like the polyglot persistence idea. And with modern deployment techniques like Docker, it is easier to deploy multiple solutions. It's not for free, but it's easier. Therefore, I observe a trend towards multi-model databases. I notice that specialized players broaden their scope and go towards this multi-model idea, not exactly maybe in the same way as we do, but they move towards this and offer more versatility. Because obviously they see this as well, and they probably want the competitive edge to be more flexible. Even relational products like Postgres or Oracle add support for JSON documents in columns. So even the traditional players, which one would have thought that they don't have to worry about anything, they go towards that thing to offer a richer data model. So that's what I observe now. And you see the news items I presented have been from this year or last year. So that's, I think, a very recent trend. And if you listen to analysts, they essentially say the same. So therefore, I forgot one. The DevOps. The term was coined not very long ago, and they gain influence on the industry. Things happen the way they like it. For example, with the Docker phenomenon. Yeah? So that's another thing I observed. Now, here are the predictions. This is the prediction about the NoSQL database market. I think in 5 years' time from now, the default approach for a new project will be to use a single multi-model database. That's the standard. So maybe 3 years ago, the default would be to use a relational database. Now the default would be use whatever is best, and well, if you have to use multiple stores, well, do it. I think in 5 years' time, the default, unless you have a very good reason, will be to use a multi-model database. The big vendors will all add different data models. That has already begun, and it will go on. And I believe that the NoSQL solutions will actually conquer a sizable portion of what now relational databases do. Simply because I think if these are flexible enough, they have a solution space which is large enough to cover enough territory that in many places they can replace the relational model. Don't get me wrong. I think in 5 years' time, still maybe 70% of projects will use relational databases, simply because they are good, they work, and for many things they are just the right answer. But I think a part of that market will go towards NoSQL because the NoSQL solutions will be flexible enough. And therefore, I think in this marketplace of 180 solutions or so, only those products will survive if they either become more flexible or they find a niche where enough people use just them because they need exactly that what they provide. So ask me again in 5 years' time. And now, thanks for your attention, and I'm happy to answer any questions now in public or later in private. No worries. Yes.
What's your sweet spot for customer?
For ArangoDB? ArangoDB?
Yeah, so what kind of companies you are dealing with and client?
Okay, so for databases, people are traditionally very, very conservative. So the sweet spot is the small company which needs to develop very fast and needs an agile solution without much effort. That is the absolute sweet spot we have at the moment. The other sweet spot, and being so flexible makes it possible to have different sweet spots. The other is if there's a use case, be it big or small, which for some strange reason actually needs different data models. Like this aircraft fleet management, or the family tree, or a new online shop. Yeah? I think that's the two things. If they really need multi-model and can profit from it, or if they are new and want to be very agile and quick in development. That's what our customers tell us. It's just great for rapid development. And at the same time, it can sustain lots of things. There's no lock-in for a data model. And so it can grow because it's scalable. And so they don't have to worry about the future and can concentrate on just getting very quick off the ground.
It's a startup.
I think that's the sweet spot at this stage, which doesn't mean that it cannot be used in big data with the enterprises. Yes?
So how should we deal with the scalability issues, both in terms of software architecture point of view and hardware infrastructure point of view?
Okay, so I don't know whether I understand.
For multi-model database.
Yes. So
let's limit the scope.
Yeah. So you see, multi-model tends to have a very rich API. So very complex queries are possible. Now, I think the basic structure can scale because it's a document store. Document stores scale well. But obviously not every query you can do can be scaled very well. Like not every SQL query you type into a relational system runs fast.
Yeah, that's right.
That's just no reason to not go towards queries which can potentially be slow. Yeah? So flexibility is the point here. And obviously you will encounter some queries. So for example, if you have not the right indexes, then the query will be slow. If you have a graph query which needs to do many network hops,
Yes.
then it can be troublesome. That is well, Neo4j has the same problem. Everybody has the same problem.
So multimodal for documentation, that's okay. For both RDBMS and graph databases, even from software architecture point of view, scalability is a serious issue. Now, forget about this hardware architecture, which is, for example, on cloud, private, public, or even on-premise cluster, scaling is an issue now. So there are two issues.
I know. I think the fundamental architecture has no problems with scaling. Obviously, you can formulate queries which don't scale. But that's then, of course, up to the software architecture designing the application, whether it needs these complex queries or not.
It's back to a CAP theorem, right? Back to CAP, because
That's
you cannot get three of them, all of them, right?
No, you can't get all of the three in the CAP theorem, obviously. And obviously, any kind of new invention cannot change this. After all, it's a theorem; it will stay true. Yeah. And again, the software architect of the application has to make the choice which of the two you want. Yeah. Do you want to be available in a network partition? Yeah. Amazon, for example, goes this way because they want to sell books or things every single second. Or do you prefer consistency? And this we can't take away from them. But what we can do is we can give them the data store such that they can have this flexibility, yeah, and make the choice on their own.
Yeah. I mean, there will be a performance penalty when you switch your model, because you have a couple of models, right? So if you switch the models, there will be definitely a penalty.
What do you mean by switching model?
Latency, yeah. For example, right now I'm at documentation model, and I would like to switch into RDBMS model or Graph model.
No, you
that
don't.
kind of switching.
No. The thing is, since it's a single store, a single engine with a single language, there is no switch. There is no switching. Therefore, there's no performance hit. It just stands there. It can support queries. Even a single query doesn't have to switch. Yeah,
but just now you mentioned, in the beginning it's schemaless. Then, if necessary, it can switch to schema-based approach, and I have to call your API. And what kind of performance? When I call your API, there will be, for serious real-time applications, there will be a serious penalty, the latency penalty, a lot of penalty.
Why should there be a penalty? Obviously, if you
any API calling has a penalty. Yes.
Yeah, but it's the same. In our solution, you have one API. Yeah, you go in, and it immediately dispatches. If you want to have, if you go to the very fast document operations, it goes directly to the C++ level. If you go to more complex things, then you go through the JavaScript path. And the only thing we add is that you can have user-defined code, which also goes towards this JavaScript. There's no penalty, other than, of course, the verification you do. But again, it's your choice. If you want to verify the schema, if you want to verify the input, then go ahead. Obviously, you need some performance for that, but that can't be helped. Yeah? There's no fundamental reason why it is in any case slower.
So a query that queries all the different types of models, isn't that going to be 3 times harder to do query optimization, or 9 times harder, or what? What is it?
Query optimization is always difficult. It might be depending on what data models you do. Yes, it is always difficult, and in the distributed world, it's even more difficult, and it's a never-ending story. So what we do, we develop this query optimizer. The query is translated into a query plan, an execution plan, and then this is optimized, it's distributed, optimized again, and so on and so on. But obviously, you will always miss some case which you haven't optimized. And it is more difficult because the language is very flexible. That's right. But then, SQL is also already very, very difficult.
And don't you need to know the schema to do good optimization? No.
That's not what we find.
No,
the optimization does not so much depend on the schema. It more depends on statistics about the collection, how many documents are there, and so on, what indices are there, and how the data is distributed.
Okay.
That tends to be more important than the schema. So therefore, we don't lose much facilities in optimization for the schema.
Okay.
And since we recognize the shapes, we also don't have, we are also quite memory efficient. That's a good question, but it's interesting that that's what we observe. Yes.
How do you make sure your data locality by using partitioning and sharding and this multi-daisy situation failure situation and drivers? How do you address that?
So, you mean data locality or
yeah, data locality.
Resilience against failure?
Yeah, basically you have one graph pointing to a document within another partition.
Yeah. Well, that is a problem. I would be telling a lie if I would say that we have solved it. So you can do a few steps, and then it very much depends on your application. So if you have a humongous graph, you distribute it in any way, regardless how clever you are, and you do the wrong query, it will be slow. Yeah, so we haven't solved this problem. So what we help with is that, for example, the very first thing you want to do is you want to store those edges which originate in a vertex on the same machine as the vertex. That's I know it's not a very classy idea, but it helps because suddenly you know what the neighbors are. Yeah? And then, of course, there are other ideas. If you know anything about your graph, then you can do the sharding according to something you know. For example, if this graph is a graph of people who are distributed all over the world, you might be able to shard by country, and just assuming that more people will be connected in the same country. And it's probably more important at this stage of the technology of graph databases, more important to have good possibilities to use the knowledge the application designer already has about the graph than to do anything very clever. And so that's what you need to do for a graph database, I would say, in this decade. You need to have flexible ways to distribute and then make the user aware of what's going on and of what's going wrong. Yeah? And that's essentially the best you can do at this stage. We have some other ideas up our sleeve, but that's a story for another talk. Yes, who's first?
You're fading out there.
Yes, no worries.
I appreciate, thank you very much. I enjoyed the talk. My question is, it seems to me that you kind of started out describing different models, and to me they're kind of like topologies, right, of your the natural topology of the data set to be able to query it. I wonder if you know of efforts, or if you yourself are involved with, like taking the queries that are put against the data set, use those queries to optimize to under the hood to automatically construct your models, add new models to your database. As a reaction to the query.
Yes. So first of all, I think at this stage neither we nor anybody does this. Nevertheless, I think it is a good idea. And what I think is that rather than changing the data model, it's the distribution of the data.
Right.
You keep the model, for example, a big graph. So you leave it a graph.
Yes.
But as I just said, the distribution of the data in a graph is rather complex, and it's a difficult problem. And what you just said is exactly what I meant when I said we have something up our sleeve, because what we want to do in the near future isn't implemented, but we have done some preliminary experiments, is to do exactly that. So we want to learn from the queries which actually hit the database and which tell you in a kind of machine learning way what data should be local. Now, after all, in a very dense graph, you might have connections all over the place, but the actual queries you do might not actually use all the connections. So what you want to do is you want to learn from the queries actually coming in and redistribute the data such that you increase data locality, hopefully, for future queries. That is something we actually plan to do later this year. We have some preliminary experiments which are encouraging, but that is one of the things. Today, graph database technology doesn't do that, but I think in 5 years' time this will be normal, and I think it will help in practice, although it will not be a provable solution to the problem.
Do they do caching? Caching?
Yeah, caching will be a part of the picture, but I think you also want to really move the data.
So is AQL a superset of
SQL?
It is not, because we tried this and failed, because SQL is good for tables and good for relations, but not good for graphic things. But your question now.
So my thing is, right now, with real-time analytics, real-time database, historical database, and big data analytics, big data stores, it's already multimodal.
Yeah.
So the de facto standard thing is multimodal approach.
Yes, in the sense that people use different data models. But I think it's not yet standard that multiple data models are supported in a single database product. And that's what I mean.
Well, I mean, single database means data store.
Yeah.
That is, again, HDFS is kind of the standard. You can store graph data into HDFS.
Yeah, you can store a lot of things in HDFS, but the querying facilities are not multimodal of HDFS. It's essentially MapReduce or read stream data, and that's it. Here was another question.
So, based on your answers to the previous question, is that I'm assuming that's a query language, but when you query the data stored in ArangoDB, you don't have to specify the data model that data you're trying to query is stored in.
No, you have
So
no.
there's a mechanism that automatically determines how to store the data, what model to store the data.
I wouldn't have put it with these words, but what happens is that you have this data in collections, and some of these are just document collections, some of these are edge collections, and then in the query language you describe what you want to be done. Yeah. So, for example, you can you can ask for, give me the documents with this and that condition of that collection. That I would call a document query. Yeah? But you can also say, okay, take this document and then do this and that graph query. For example, find the shortest path to some other place, or explore the vicinity of that in the graph. So in that sense, it's you saying what you want queried, and the database just then selecting whatever method is best for that.
But then when you load the data into the database, does it automatically figure out which data model is best for your data?
No, it doesn't do that, and I think it would not be working well. What you have to specify as the database engineer or somebody who does the programming, you have to say what kind of data in what model to store, but you have the selection. You have choice. You choose, and then you put in the data in the right format. Yes?
So you gave a couple of examples of aircraft industry and family tree. Any specific industries which are popular, where your product is popular right now, or specific use cases where this product fits the best?
Yeah, so I've picked these examples because they very much show that people need multimodal for their different queries. And I think this is what is one thing which is popular. But you see, another company might say, we just need a document store at this stage. And yet another company might say, what we need is a graph database, because we have a graph. And what very often turns out is that they use us or some other product at first glance for a specific purpose. And then later on they notice, hang on, wouldn't it be nice if we could do this other data as well in the project? Yeah? And typically this happens with graphs. So we have a lot of people who start by saying everything is a graph, and notice later that rather a document store would be more convenient. And they have the advantage with us that they don't have a data model lock-in. Yeah, so they don't have to stick with the single data model they thought in the beginning is the right thing. And I think this is you asked for the sweet spot. This is another answer to the same question. I think what we observe in our customers is that they like the flexibility. They like no lock-in with the data model, and they like that they can use it in a very high-performance, distributed, scalable way, and at the same time in a maybe not so scalable but also useful way with transactions and asset guarantees and complex queries. Maybe even in the same product. For some small part they want to use the complex facilities, and for some other product they want to use the scalable facilities. And so this choice, this is the common thing of our customers, what we see. They
Just
like
if
flexibility,
I don't know-
choice.
If I don't know where it's going to go, I can take your product and
Yes.
then
Just be relaxed. You will be fine in 5 years' time. Yes.
Okay, yeah. Does AngularDB has auto sharding and auto replication like MongoDB? Yeah?
So we have automatic sharding, so you can deploy a cluster, and the data, you say this collection is to be sharded, and then it's automatically, the data is automatically distributed. We have also asynchronous replication, that is to a running database server, you can just attach another one and it replicates with eventual consistency. Yeah? And one of the next things on our roadmap is synchronous replication in the cluster and automatic failover. This is not released yet, but we are working on it.
So does it support a self-provisioning? Is it being run on AWS, like a Google Computing Engine, Backspace, OpenStack, one-click spin-off?
Again, we have for the single server image, we have one click for Amazon, Azure. We are working at the thing with Google. It's easy on DigitalOcean, maybe not one click, but it's easy. And so we are hard at work to make this. And again, very, very soon on our roadmap will be the one-click solution for cluster.
Okay.
We are not yet there, but this is very important. We recognize this. And the other thing is we are closely cooperating with Mesosphere, because they seem to have a very nice cluster management system. And we will integrate with them such that on a Mesosphere or Mesos cluster, it is just another framework which you scale up and down as you want, and your resources in the cluster are used nicely. Again, that's in the works. Part of the reason for our visit here now is to talk to Mesosphere, cooperate with them, and make the integration seamless, because I think that's the way to go. Yes?
So Max will be around.
Yep.
So we'll start the next session. So we'll have a 8-minute break. Come back at 3:05. So thank you, Max.